In the heart of our most advanced machines lies a hidden ingredient, high-purity alumina. It's the ceramic backbone of the semiconductor world and the firewall inside every high-performance battery. Without it, our smart world goes dark.
For decades, the tech industry has had a dirty secret. Producing this white gold was an environmental nightmare. Energy-intensive, chemically toxic, and almost entirely controlled by foreign interests.
HPA is used in many of the advanced technologies. Predominantly it's used in semiconductors, LEDs, lithium battery technologies, and increasingly in data centers as well.
But in a modest facility in Perth, Western Australia, a team of engineers has developed what they claim is the Holy Grail, a way to produce HPA that is not only ultra-pure, but ultra-clean. The current method of making HPA is a brute force process. It involves taking raw aluminum metal and degrading it back down through a series of expensive, high-heat chemical reactions.
So the traditional high-purity alumina suppliers either take aluminium metal and then degrade that back to the oxide form, and that is quite an expensive and capital-intensive process.
Beyond the cost, there is a geopolitical price as well. While the West builds the gadgets, China builds the material.
As with most advanced materials, China dominates production. The total market is around 65 to 70,000 tonnes. China produces around 75% of that.
Of course, it doesn't surprise me that China's such a big player. The United States doesn't want China to have such a hold on this market, obviously. I'm sure there's been a lot of discussion about that, and that might be why you're going to have a plant here in the United States. Is that tracking at all?
That's very much our strategy. There's really no domestic supply chain for high-purity alumina.
We are effectively building a 21st century economy on a 20th century supply chain. If that bridge collapses, the AI revolution stops on a dime.
So how do you disrupt the monopoly that's developing in China today? You don't outbuild them, you outthink them. Aluminus has abandoned the high heat, high waste methods of the past.
Their secret is a proprietary solvent extraction process. Instead of massive, rigid furnaces, they use a series of chemical filters that pull pure aluminum out of a liquid solution with surgical precision. It's cleaner, it's faster, and most importantly, it's modular.
The other key benefit for our process is scalability. We use a solvent extraction process which is easily expanded. Expanding capacity means expanding the size of the tanks, not a difficult process.
Think of it like a micro versus massive industrial brewery. They can start small, prove the purity, and then scale up simply by adding more to the system. No massive infrastructure overhaul required. In the world of ultra-high tech, purity isn't a goal, it's a survival requirement.
Most companies can hit 4 nines purity, 99.99%. That's fine for your standard LED light bulb. But if you're building the next generation of NVIDIA AI chips, Tesla battery cells, or Apple iPhone, you need more. But I want to ask you about it because we've been highlighting the applications across semiconductors, batteries, optics, AI infrastructures, aka data centers. How do you think prioritizing these in markets, and where do you see the strongest near-term demand, I guess I should put it? Who comes first?
The real focus for the business is on the semiconductor market because that is where the near-term growth is coming from. The requirement from the semiconductor space is 5 nines purity, which is obviously a level up in terms of processing from the 4 nines purities.
10 parts per million. That's like finding 10 specific grains in a ton of sand.
The 4 nines purity generally goes into batteries, so the first step will probably be going through the battery gigafactories. That will provide the bulk, and then as we refine our process and get to that 5 nines consistently, then the semiconductor market will take over from there.
By reaching the 5 nines threshold, using a low energy process. Alumina isn't just entering the market, they're resetting the bar for the entire industry.
There is another reason the world is starving for HPA: heat. As AI models like ChatGPT and Gemini become more powerful, the chips running them are getting hotter.
If these chips can't shed heat, they throttle. If they throttle, the whole system slows down. HPA is the key to keeping this digital world cool.
It's very thermally efficient, so it removes heat very well, which is why it's used in data centers, it's used in high energy semiconductors. It's that thermal management capacity that it brings to the table. Thermal management is one of the key aspects of running an efficient data center, and Alumina is a big part of achieving that.
It is the ultimate paradox, the world's most ethereal technology. Artificial intelligence is physically dependent on this specific ultra-pure earthy powder to keep from burning up. The finish line is no longer in Perth. The target is now the United States. Alumina is currently shipping samples to major battery innovators like C4V in New York, moving toward a full-scale 2,000-ton American facility.
But what's most impressive isn't just the supply chain security, it's the footprint. While the rest of the industry struggles with greenwashing, this process is built for 2026 standards from day one.
The process that we've got compared to the current technologies is very low power consumption. We do use a fair amount of water, but we're going through the process of recycling that. So we would envisage ourselves being water neutral, if not water positive, and putting clean water back into the system.
It's a rare story in evolving tech. A breakthrough that is better for the investor, better for the national interest, and for the first time in Alumina history, better for the planet. For the future of tech, it isn't just about what we build, it's how we power it. For Small Cap Voice, I'm Stuart Smith. Thanks for tuning in.